Alright, so here we have a cart that has a mass of 5 kilograms, and it is attached to a mass on the right side, actually two masses, and a mass on the left side. Now, the masses on the right side have a greater force of weight than the masses on the left. So we know we have a positive net force, and therefore we're going to have a positive acceleration. So let's answer these questions. How many normal forces are acting on the cart? Well, the normal force are the forces that surfaces apply to objects. So we know that there are normal forces being applied to these wheels. And we can only see two wheels, but we know that there are 4 on this car, but we can only label 2. So we have these normal forces, and how many? There's actually 4. Draw the normal forces on the cart. Okay, we did that, so we can check that off. How many normal forces are acting on these hanging masses? Well, since these masses are hanging, and the normal force is the force that a surface applies, there's actually none. No normal forces on these masses. These masses actually do have a couple of forces acting on them. The force that is being applied downward is going to be the force of weight. And then there's also a force pulling it upward, which is the tension force. Alright, so moving on. What force is acting on all of the cart and on the masses? Well, since it's on Earth, we have the force of weight. So it says calculate the force of weight for the cart. Well, we have an equation for force of weight. It is mass times gravity. And we know that the mass is 5 kilograms. And that our gravity is 9.8. So we're going to multiply 5 by 9.8, and we get 49. So this has a force of weight of 49 newtons. And technically, since weight always is applied downward, it's 49 newtons down. If the cart is moving, is it accelerating or at constant speed? Well, we know that the masses on this right side are greater than the masses on the left. So we know that the sum of our forces is going to be positive. And if force equals mass times acceleration, we know that if our force is positive, our mass is 5 kilograms. So that's non-negotiable. That's not going to change. Our acceleration has to be positive. So if the car is moving, is it accelerating? Yep. It will not be moving at a constant speed. And why? It's because we have a net force, which is positive. Alright, and this has to do with Newton's first law, the law of inertia. Basically, sorry, we have the bell here. Newton's first law of inertia. Basically, an object at rest wants to stay at rest, and an object in motion wants to stay in motion unless acted on by an outside force. Well, this outside force happens to be this additional mass. So it's creating an acceleration, so the object is going to be speeding up. And this actually has to do with Newton's second law as well. Newton's second law basically says that the acceleration of an object is directly proportional to the object's force and inversely proportional to its mass. So the greater the force, the greater the acceleration. And all this really means is force equals mass times acceleration. So the greater the mass, the less the acceleration. But the greater the force, the greater the acceleration. So we have the mass is the same. We're creating more force on this right side, so we're going to have more acceleration on this side.